Okay, so let's start our talk. So today's topic is machining allowance. Okay, so last class we have covered shrinkage allowance. There we have talked that there are two types of shrinkages. One is liquid shrinkage and another one is solid shrinkage. Lagging is there. Wait, this lagging is due to some problem. Wait a minute. Okay. So during machining allowance, shrinkage allowance, what we have discussed that there are two types of shrinkages. One is liquid shrinkage. Liquid shrinkage. What is the shrinkage which is happening during cooling of the molten metal from pouring temperature to uh, its melting temperature or freezing temperature. And another one was solid shrinkage. So this was actually in case of solid metal. Now liquid shrinkage was compensated by providing riser, and this was compensated by providing shrinkage allowance. This was liquid shrinkage is represented by percentage over volume, and shrinkage allowance is represented by percentage over dimension. Either it is percentage or it may be directly, it may be given like millimeter per meter over dimension, over each dimension. So that is the differences we can understand if the allowance is given percentage over volume, or it may be something like millimeter cube per meter cube, something like that, then it is liquid shrinkage. And if the allowances are given like millimeter per meter over each dimension or percentage change dimension, that is solid shrinkage. And solid shrinkage is compensated by providing shrinkage allowance on the pattern. Shrinkage allowance is provided over pattern, so we add shrinkage allowance on the pattern, and but riser is provided in the mold. While making the mold, we provide the riser. So these all things we have talked in the last class. Then we told about one thing, that is uh, double shrinkage. So double shrinkage is provided in case of when the pattern is made up of metallic. So in case of metallic pattern, double shrinkage So last class we have talked about this, and after that we talked about shrink rules. So shrink rules, actually it is having larger dimension. It is having the larger dimensions than the actual like actual scale, or you can say that uh, here the 1 millimeter will not be 1 millimeter. Actually it will be 1 plus some of the dimension, that is the millimeter. So this is actual dimension, but this is on the actual scale, but it is on the shrink scale or shrink rule. It's about that. So much noise. Okay, so these all things we have discussed in the last class. So now we will proceed further in machining allowance. So machining allowance, why it is provided? So machining allowance is actually the extra dimension which is provided on the pattern to compensate the loss of material from casting while machining. So obviously we know that why this machining allowance is provided on the pattern. So we have seen already the pattern. Let's suppose this is a pattern, this is a casting which is to be made having the dimension 10 mm. So this is the pattern. So it is made little bit, the dimension is increased. So this 1 mm which is increased here is basically which one? It's the, this is increased to compensate, or you can say because we are going to machine, so we to have this casting. So what we are going to do, if the solidified casting is this one, then we will remove this extra material and we will get the exact size. So why this extra material is to be removed by machining is because of some regions. So let's see what are the regions. Three regions are there. First reason is that we need surface finish. Okay, because during casting there may be chances that some sand is there sticking over it. So there is a chance, there is a problem that that the surface will not be so clean. So sand will be sticking over here, or there may be chances that some some effects little bit on the surface you will find. So that is not giving you good surface finish. So to acquire that desired surface finish, we go for machining. Second one is to achieve desired dimensional accuracy. Okay, so what happens that when you are doing casting, or when then there will be cooling. So there is a chance that right now it is a cold season, so the temperature in the room is maybe 5 degrees Celsius. It may happen that the temperature inside the room is 5 degrees Celsius right now. But what you have done, you have designed the pattern based on the room temperature 25 degrees Celsius. So obviously there will be a change in the dimension. You have predicted that this much should be the dimension, but because the due to the cold season the temperature is very very low, and due to that the pattern or the casting will shrink more. So in that case what you will not get the exact dimension. So in that case, to change the, or sorry, to get the desired dimensional accuracy, we go for providing the machining allowance. other factors are also there. It's not only that the temperature change. There may be other factors, like when you are like there is a, let's suppose you are using some gray cast iron.